Well, they're not asking you to prove that it's true, they're asking you to find what makes it true. Okay? Now, your overriding goal, Nabi, are you cool? Your overriding goal with trig equations is to get to what's called the peanut template, technical term. Who's heard of this? Doesn't ring a bell, Sophie? No? Okay. Basically, all trigonometric work is premature. Like, you know how I said there's lots of ways of doing trig. You can swing around the circle, you can use the calculator, you can use the 3x3 table of famous results. You should never do that until what you're looking at absolutely 100% fits this template. It can look like this. Sine peanut equals Christmas tree. Yeah? That's one of them. Or cos Apple logo equals iPod. Tan funky video camera equals chair. Okay? Now this does not look like those, right? It almost did. If only that was sine, it would fit the template, right? Because what's playing the role of the peanut? 2 theta. What's playing the role of the Christmas tree? 0.6. So you have to bust your gut until you can write down these. Okay? Now in core 2 you saw some pretty beastly ones which looked a million miles from that, and you had to use all sorts of clever tricks to make those sorts of things appear. But I'm telling you, do not feel you can reach for the calculator or reach for your 3x3 table or swing around the circle until you're looking at that. Nabi, are you cool? So, in this case, we can actually make that look like that pretty quick, but before we do that, we have to spot a massive trap. This is a very famous trap in the world of trig equations. What is that trap, Mahum? This is going to wreck us unless we notice it right now. There's something special about this question. Jody? Yeah, but that's always there because remember, trigonometric equations go on forever. I always call that the permission statement because it gives you permission to stop doing the question and actually go on to do something else. Because if I really did say, what are the solutions to sine theta equals 0.5, you could go on forever, right? Because you could just keep swinging around the circle. So 30 is 1, 390 is 1, 36 million and 30 is 1. You're just going forever, right? So a lot of people call that the range, some people call it the domain. It's a bit of annoying because they're technical terms from another chapter. I call it the permission statement, right? Gives you permission to only write some answers down instead of all of them, or millions of them, or a million bisquillion of them, right? So what's the trap, girls? I'll tell you the trap. Huh? It's clearly a degrees question.
Well, no, but that's, you have to check whether it is or not, don't you?
Yeah, but that's pretty straightforward. That's not that much of a trap. Yeah, this. Girls, you must be on the lookout for when what the trigonometry applies to does not match what's in the permission statement. That is death. But it's got a very simple fix. The fix is to do red dudes on the permission statement until it does match, which in this case is very simple. Okay? You just times everything by 2. And now it's not. This does match this. Okay, now, I said before that sometimes you really had to bust your gut to make it fit the peanut template. This one you don't. You just go like this. What's 0.6? 3 over 5? So therefore, tan 2 theta is 5 over 3. Now, multiple choice question out of 4. How do we solve this guy? We'd swing around the circle. We can use the 3x3 table of famous results. We can use the cool thing about how big angles questions become small angle questions. And what's the other way? Just pick up a calculator, right? Which of those is best for this? How do you know when swinging around the circle is sweet? It's when that number is like 1 or 0 or negative 1. Okay, how do you know when the 3x3 table is sweet? Well, when that is one of the things in the table. So like, you know, root 3, root 2 over 2, half, that sort of thing. This is none of those, so just reach for the calculator, get a basic answer. What's the basic answer? Has somebody done it? 59.04 degrees. Now, do not divide that by 2 yet. Okay? Basically, this whole question is now about 2 theta. It will only become about theta at the very end when we present our final answers. Now what you do is, you go and tuck this guy against the x-axis in all 4 possible ways, thereby generating an X-Wing fighter from Star Wars. Do I need to explain my pop culture reference there? Does everyone know what an X-Wing fighter is? No? Man? Who hasn't seen Star Wars? There we go. They look like that, right? Oh, can you see it? Just got an X-Wing. So I always think of these guys as like an X-Wing fighter. Okay, so your so basically you tuck 59 there, you tuck 59 there, etc. And now you rule 2 of them out. Because it doesn't equal -5/3, it equals 5/3. So which ones get the chop? It's a tan question, so that one and that one stays, these one and these ones go. Is everyone clear on that? It's because of this cast business. This is where all 3 of the trig ratios are positive. This is where only tan is. Here, cos and sine are positive, and we don't want that. Okay, you now have to work out ways of quantifying these 2 ticked angles using what is permitted to you. So 59 is clearly permitted. What else is permitted? Going an extra. 419.04. Being a bit naughty here because these are actually decimals that never end, I presume. So